Once again, this is our schedule, and this is my idea. You learned everything to do with 90-degree triangles. You learned anything to do with so acute triangles that don't have 90 degrees, and you learned that you can use an acronym or whatever. We're also learning cosine law, where you can deal with triangles that are not 90 degrees when you're given certain information. You might be asking at this point, why has there been such a focus in triangles for both grade 9, grade 10, and now grade 11? So I'm going to take you on a little bit of a break. Okay, so be mindful of this. I am going to bring this back in just a second, but let me just save it. Let me raise this up a little bit and bring it back down. All right, everyone looking up here, I have a single dot. How many sides do you see in this single dot? Not a trick question. Just look at it. How many sides do you see? Sides. None. It's just a dot, right? Like, it's a dot. Do you see a side? No, right? Let's move on to 2 dots. If I were to connect the dots, how many sides do you see? Sides. Sides. How many lengths? 1. How many corners do you see? Well, it's still not really a shape, right? Once we start looking at this as a shape, right? How many sides do you see? Sides. 3. There are 3 sides. Everyone with me so far? I'm not trying to confuse you here. Now I'm going to switch up the question. Now that you have 3 sides, how many triangles do you see? Yeah. Just 1. Okay. I connect the dots. How many sides do you see? 4. How many triangles do you see? You get where I'm going at, right? Yeah. A square or a rectangle, you could look at it as if it was 2 triangles connected to each other. I'm going to connect the dots. How many sides do you see? 5. How many triangles do you see? Right? If you want to figure out or work with a pentagon, you can actually pretend it's 3 triangles connected to each other. So if you have the skills to deal with this triangle and this triangle, or this triangle, put them all together, you're actually dealing with the pentagon. And I could go on forever. How many sides? 6. How many triangles? Well, there was 1 triangle, there were 2 triangles, there are 3 triangles here. It makes sense to have 4 triangles. Do you get the point? Now, I am going to go a little bit further. Why is this such a big deal? 1, 2, 3, 4, 5, 6. Oh gosh, 6, 7. That's a terrible heptagon. But I think you understand that there's going to be 5 triangles. Now I'm going to go continue on, and pretend that there is an infinite number of sides in this shape. And if I were to connect the dots, well, there's an infinite number of triangles, right? What does that shape look like? If I were to connect all the dots, that shape looks more like a circle. So if you ever venture out into university or whatever, you will see that even a circle is talked about as a million triangles touching each other, connected to each other. And so essentially, back down here at a elementary level, even in grade 1, grade 2, grade 3, the first shape you start learning about is a triangle. And there's so much weight in that because as you progress through middle school, through high school, and then to university, you're using that knowledge to further bigger and better things. But for our purposes, we need to make sure we can understand, or we can work with a triangle inside out. Why? Okay, so here it is. Once we learn all the different ways we work with SOHCAHTOA, sine law, and cosine law, I am going to give you questions where two triangles are connected to each other. Of course, yes, they are in the form of word questions, and I'm going to challenge you, and I'm going to do these examples with you before the end of class, and essentially expect you to do as much practice as possible so that tomorrow, when we have our double period with OSSLT, we will be able to do our assignment. Okay, so yesterday recap SAS, today SSS. We'll wrap up with chapter 5.5 multiple triangles. Tomorrow, first half of our class, if the weather permits us, we're going to go outside. So you might want to bring a jacket. I'll have everything else for you. Part 2 is an in-class thing. You could work with groups. You can work by yourself, whatever. I'm going to give you essentially 2 large word questions for you to do. And you must hand both of these in before the end of class. Part 3 is a take-home. And that you can have the weekend for. It's not a long project, but you do have to stay focused. Any questions about where we're headed? Once, twice. All right, let's finish this off. Today, I'm going to look at a question that does not give you an angle, but expects you to find it. Consider this. This question gives you 1 side, 2 sides, 3 sides. It is a situation where S is clearly visible. Yes? Pardon? This is from yesterday. So if you have yesterday's sheet, take it out, please. So as a recap from yesterday, we did question example 1. I showed you that example 2 is very similar. And the homework was number 5, A, B, and C, I think, something like that. You know what? As a recap, I've set my boundaries, I suppose. Any questions from number 5? We might as well look at this first because I don't want to go over this if you haven't done it. You're going to be stuck. All right, instead of waiting for an answer, I'll just say, who would prefer that I do one of these questions just to refresh? All right, well, yeah, Micah, you too, for sure. A, B, or C? Micah, A, B, or C? Okay, all right. Triangle A, B, C. I am going to just draw a random triangle because I don't know what it's supposed to look like. And I'll call this A, I will call this B, and I will call that C. All right. Based on this, again, your triangle might look different, but based on what I drew, this side should be little a because it's opposite of angle A. The bottom side should be little b because it's opposite of angle B. The left length should be little c because it's opposite of angle C. Let's label. Angle A was 68 degrees, so this is 68 degrees, and it has to be a corner. Length B is 10.1, so I'm going to erase this and write 10.1. Length C is 11.1, so I will erase it and write 11.1. I'm just going through the motions, making sure I don't make any labeling mistakes, because as confident as you might be in your cosine law, if you do not have the right triangle, it's going to be a little tough. Okay, next, I'm going to do things a little different from yesterday. I'm going to take a highlighter and highlight the angle and side that is either given or that I'm curious about. So clearly, this side is what I'm looking for because it's unknown. 68 then is my matching angle. That is going to go on the outer side of my cosine law. And please don't be confused. I know that right now it says C and big C, but are those two values 68 and A? No. Keep in mind the outer edge, so the C squared and my angle C should actually be the pair that I'm trying to figure out. Don't think just because I wrote the letter C that you have to plug in C. These letters are just, symbols, okay? This particular case, you can rewrite it so that the A values are the ones on the side. So little c, length C is actually going to be written as, let me write it in blue so that you see a difference. Unknown A squared is equal to 10.1 squared plus 11.1 squared minus 2 times 10.1, 11.1 cosine of 68. Once again, let me highlight it. This side is what I'm looking for, and the angle is given here. You must match it with the outer, the outer edge values need to be the pair that I'm looking for. So you may not like how I wrote it here. Write something that reminds you. How about I write outer letters or outer variables are my unknown pair. Maybe that might help. So this equation that I'm giving you here, this equation that you see from yesterday, all you need to do is learn how to plug in the numbers. Not be fixated on C, A, and B being exactly where they are. You need to be flexible. The two outer numbers are the angle side pairs that you are interested in. Yes? It's like 1 plus 2, 2 plus 1 doesn't matter. 1 times 2, 2 times 1 does not matter. All right, so the next is just solving it. If you get to here, I'm going to tell you right now, drawing a correct triangle will be 1 mark. Plugging in the right answer, the numbers will be another mark. Getting the final answer is only 1 mark out of the 3 that I might give you. That's how important these 2 steps are. You have to get the right triangle and the right numbers in. Cameron?
You just solve it so you can.
Yeah. Now that we have everything, we're going to solve for A. Not A squared, we're going to solve for A. So I'm get my calculator. Everyone can follow along too. See if you're doing this right, because a lot of people will probably make some mistakes carelessly on their calculator. 102.01. Then 11.1 squared is 123.21. And then this thing, 2 times 10.1. This is 83.99. So A squared will be 99. Yeah. Wait. I said let's do 3 decimal places when we round, right? 102.11, 102.01 plus 123.21 minus 83.994. I get approximately 141.226. That means A is going to be rounded 11.884. This side right here is 11.884 centimeters. I know it's a little messy, I don't have much space, but I hope you can read that. Once again, the formula, you can have it on your study sheet, you can bring it with you to tests or exams or whatever, or quizzes, sorry. It's all about getting the right triangle and plugging in the right numbers. So that is what I need you to practice every time. Like, I know you can plug things into the calculator, right? This part, the colorful part is so important. You can't do that by thinking on your own, then we're not gonna get anywhere. How can you do it? How can you get anywhere? And how can you do it without practice? Yes. If you are given your side and the angle is unknown, that means you would have this number and this would be a theta or some unknown. So you still have the entire equation or formula full, except for one unknown. And you'll solve for an angle. We're gonna do that right now, right? Because this was yesterday, the angle is today. You have all the tools you need for multi-triangles. Yes?
For a squared, I got 151.26.
I'll try again. But if I get this here, then I'm gonna ask you to try again too. Minus 2 times 0.1 times cosine 68. No, I think I'm good. One of these must be wrong. Do it one at a time and see which numbers might have a discrepancy. Okay? For everyone else, let's move on to when we have an unknown angle. So I appreciate that Charlie mentioned that. Okay? Up until now, I gave you the angle. This time, I do not. So once again, look carefully at this triangle and notice that it is going to be side, side, side. That's given to you. So you know it's cosine law. Step number 2. What is my angle side pair that you are interested in? So write this up. We have, remember, c squared is equal to a squared plus b squared minus 2ab cosine c. But please don't be fixated on the c as this c and this a as that a. That's not true. You have to be flexible. The outer numbers here of this equation correspond to the angle side pair that you are interested in. So what is the angle side pair I'm interested in? For this triangle, what letter? In this particular case, I am interested in B, and the pair, the side pair that comes with it is 12. So I'm going to plug it in. My B is here, and I don't know what that is. I'll put that as a theta, I guess. And then put that in blue. Okay, I'll write that as a theta. So C this time is my 12 squared. My A, I'll write it as 8 squared. My B, 10 squared minus 2 times 8 times 10 cosine angle B, or angle theta. Does everyone notice? My C, again, I'm being flexible. I'm writing it in my head as B because that's the angle side pair that I am interested in. Now let's calculate all of these individual operations so that we can make better sense of it. Please note, from here, put a little star next to your note and write down algebra, okay, in order of operation. All right, I'm going to simplify this. 12 squared, 144. 8 squared, 64. 10 squared, 100. And then, I don't know what cosine B is, so I can't solve it. Negative 2 times 8 times 10. Negative 160 cosine B. All right. And here's what I mean by order of operation. I want cosine B all alone. I'm going to get that all alone by removing everything else. So take a look. I'm going to subtract 64 from both sides. Reverse bedrest. I will also subtract 100 from both sides. So let's solve that first. Oh, did you already write the subtractions? I'm wondering if I should just add 164 and do it in one go. Would you prefer that? Yeah. I think some people might appreciate that more. So if you understand what the heck I'm doing, I'm going to rewrite it. 144 equals 164 minus 160 cosine B. Oh, Sage, you don't have to. Do what you want. Do what you want. Okay. From there, we've got, so I will subtract by 164 and subtract by 164. The left side becomes negative 20. The right side becomes negative 160 cosine B. And then what's next? This might seem familiar to some of you. Put it down. Sorry, I thought I had a name written down for you. But anyway, there you go. Yep, exactly. Oh, speaking of which, Micah, there is a quiz that you ought to be doing. Did you know about this? Okay, I'll talk to you after this lesson. Okay. So divide both sides by 160. I'm just going to do that right away because I think you can follow along. 20 divided by negative 160. I get positive 0.125 equals just cosine B. I divided negative 160 from both sides.
Because, oh, you're dividing by negative 160.
Correct. Yes. Again, I want cosine B all alone. So I know that there's a multiplication between these two. So I divided both sides by negative 160. So this is, that is negative 20 divided by negative 160, and I get 0.2125. Okay, and then suddenly we go back to SOHCAHTOA. How do you separate the cosine function from the angle? It's part of your quiz. Inverse cosine. So you can't do that without a calculator, or it's very difficult to do so. So B is equal to 82.819. So 3 decimal places, 82.819 degrees. So yes, a little bit more steps, a few more steps than when you had SAS, but you'll see this again and again. Watch this one more time and then we'll try B together. I'm gonna take my time and let you try. So whatever you wrote down here for example 3A, see if you can reproduce it for 3B. So literally, you can actually copy our exact steps here for example 3B, but I do want you to struggle and see where you get stuck and spend a little too much time. I will pause the video. I'll give you exactly 3 minutes to struggle. Are they finding progress this way? It's good. Let's get started. Once again, I would prefer, it's my habit to have the equation in front of me. C squared equals A squared plus B squared minus 2AB cosine C. I like to have it in front of me because I prefer to just plug in numbers if I have that choice. Next, what numbers do I plug in? I appreciate this triangle because there are no ABCs, so there's nothing to confuse you. What is C in this case? Well, angle, side, that's my pair, right? I'm looking for this top angle, so that has to be here. Let me draw it. That is my angle, so it has to be there, which means my side pair has to be there. Using a different color, let's highlight. This is my angle C, and this is my side C. So let's plug it in. 5 squared is equal to 5.5 squared plus 5.3 squared minus 2 times 5.5 times 5.3 times cosine 5. Oh, how am I doing? Cosine, let's do angle D. Next, I am going to start working through the algebra. That was my next step. 5 squared is 25. 5.5 squared is 30.25. 5.3 squared is 28.09. And then negative 2 times 5.5 times 5.3, negative 58.3 cosine B. All right. The rest is all just trying to get this all alone. Just because I did it last time, I will simplify again. 25 is equal to 30.25 plus that, 58.34 minus 58.3 cosine D. I know the numbers seem similar, that's just more coincidental. You don't have to feel like it's a little weird. Next, let's subtract 58.34 so that I get this term all alone. This gives me 25 minus 58.34, negative 33.34 equals negative 58.3 cosine B. That means I can get cosine D all alone by dividing both sides by negative 58.3, giving me 0.572 rounded. So the inverse cosine is what I'm looking for. Angle D is going to be 55.11 degrees. Yes. When I'm choosing the sides. For A and B or for C? Yeah, yes, it does. So A and B, it doesn't really matter what order it is. However, C and big angle C are always going to be fixed. So take a look at where I highlighted. When you look at a triangle, always look for what angle and its opposite corresponding side is going to be. So in the first triangle, it was this angle and that side. Correct. Correct. That goes into that highlighted C position. All the other sides, this and this, go into here and here. Again, as a recap, if you can do SOHCAHTOA, if you can use sine law in all the ways that you saw in the quiz, and if you can use cosine law now to solve for angle or side, you have everything you need for multiple triangles, for squares, rectangles, pentagons, hexagons, you name it. My final example for today is going to come from the next section, 5.5. Just to give you an example of what you may be required to do, and how two triangles can be next to each other, and what the main goal is. Okay? Any questions about this question? I know you'll probably need more practice. Okay? So I'll come back to this video if you need to. I want to show you one example before we go to it. So if you don't have this sheet yet, please get one from the front. I'm just going to do the first example for you to show you how all of these tools are connected. First, I'll tell you my game plan. I will tell you the story that I'd like you to follow. And then from there, we're going to try doing the math. Cameron, you with me? Brendan, you with me? Please consider this. Given the diagram below, calculate the height of a cliff. So watch this. Let me read the entire part. At this point, again, assuming that we would have kept up with the schedule, I am assuming you are able to do SOHCAHTOA, that you have the ability to do sine law, and you have the ability to do cosine law. The difficulty of these word questions are going to be figuring out what the heck they want, and then the game plan to get there. Yes? No, it's in front. All right, question 1. Given the diagram below, calculate the height of the cliff. You may notice that this height is part of a 90-degree triangle. It just happens to be in 3D. So let me see if I could sketch that out. If I were to take that triangle and draw it as a 2D object, it would look like this. Does everyone see that triangle as a 2D triangle like that? Can you take that little pointy thing and flatten it on a piece of paper? I wonder, because that is going to be important when we're dealing with 3D. Next, so if I were to calculate this height, which of my tools do you think I could use? Cosine law? No. Sine law? Maybe. Just from looking at the triangle, what would you suggest? Brendan? SOHCAHTOA. I have a problem though. Which ratio from SOHCAHTOA would I use? Yes? Possibly. But if I wanted to use TOA, what do I need? I have the opposite here. That's what I'm looking for. I would need this side, right? This side right here, let me highlight it in red, is right here. How do I get information on that side?
By doing another triangle.
Yeah. So before you even get to that first triangle, you have to move to the previous and see if I could redraw this. 1, 2, 3, 42, 63 degrees, and 68.5. I'm looking for that side because if I could find that side, it automatically fills that triangle, and so I can use SOHCAHTOA. Well, how do I solve this one? Based on the information given, let's look at what we learned today. Is this an example of side, side, side? No. Is this an example of side, angle, side? No. You're gonna have to use sine law. Thanks, Alex. I appreciate that. So, knowing that side, so it's angle, side, angle, so it's sine law. I'm gonna do this for us, all right? 42 degrees. So how about I label this? I need, let's call this X. Let's call this, no, I already have letters. What am I doing? So this is D, that's C, and that's B. So this would be little d, that'll be little b, and that'll be little c. 60, so let's see, 42 degrees is with little d. 63 degrees is with little b, but I don't think I'll need that. And angle C is with 68.5. Going back to our sine law, I think we can find angle C. So angle C is equal to 180 minus 42 minus 63. That gives us 75 degrees. Now that I have 75 degrees, I'm going to set up sine law. We have okay. 68.5 over sine 75 is the same as little d over sine 42. This is also equal to little b over sine 63. I'll wait for people to catch up. There's a reason I wrote D before B. It's because I don't need that. So that it fade away, fade away, fade away, fade away. You like that? No? No? Not fun? Okay, not fun. All we need is the letter D. So why bother with, you can write it, nothing wrong with it, but no, be focused on your goal. My goal is to find the D value so that I can place it on my right angle triangle. Now there's a level of thinking that you want. Okay, let's solve it. 68.5 divided by sine 45. Sorry, sine 75 is approximately, I just did it in one shot, approximately 70.916. This is D sine 42. You know what? Let's do sine 42 so we have all numbers. 0.669. That means 70.916, I want to multiply both sides by 0.669, and I get 47.443, which means my right angle triangle 47.443. Now we can do TOA, we can do tangent. We've got tangent 38 degrees is equal to the height, so which is opposite, over adjacent. So height, I'm going to assume, whether I'm doing it right or not, I'm going to assume that you are able to do this question because you know how to do self-control. The height is approximately 37.07. So look how long that is. And I do expect it to take you a decent amount of time. Number one, because you have to figure out a game plan. You got to figure out, what am I going to do? Like I did. I wanted height, but if I wanted height, I need to decide, where do I get the side? From the other triangle. How do I solve the other triangle? Sine law. It was long. Once you make that conscious decision, this is going to be my step-by-step game plan. You have to remember how to do the math so that you can calculate your D side, so that you can transfer it over to the previous triangle, so that you know to use tangent, so that you can calculate it. It's long. It's long. But the reason why we focus so much on the triangles, so that each calculation will be done back to back without trouble. Yes, sure. Okay. Very important that you're able to work through this. I'm going to stop right there because you will see more examples like this. I'm going to move around to help people who might have their own personal questions with this. But tomorrow, you know what my expectations are. We are going to do a 3-parter assignment. The first part going outside and collecting data in the first half and finishing it off. You should be able to, because it's going to be very straightforward. And then part 2, there's going to be these word style questions that we do together. You could work in groups or individual, whatever, in class. And then a small piece you take home for the weekend. Question? No. The outside portion, it will be like, if you're efficient, we'll probably be there and back in like 30 minutes. Okay. I could give you a quick, what is it? Hint of what's happening. Every group, whether it's a group of 2 or 3, is going to get one of these. You're going to measure a certain distance, and I'm going to give you a little tool that helps you measure angle. That might give you a hint of what we're doing, because we did something like that in class before. You remember that, right? I was standing over there. So, we can do something like that. I'll give you more hints of how you can set up your assignment better tomorrow, so stay tuned. Any other questions?